Okay, again, we're still factoring polynomials. So we're going to just use general strategies in factoring polynomials. So always look for a common factor. If there is one, factor out the GCF. Then we're going to look at the terms. If you have two terms, you're going to look and see if it's a difference of perfect squares. If it's three terms, you're going to see if it's a perfect square trinomial. And if it's not a perfect square, then you're going to try to factor by unfoil or grouping, whichever one that you want to do. And then I call it the AC method. And then four terms, try factoring by grouping if it's four terms. So to factor a polynomial, always factor completely. If the factor with more than one term can still be factored, you should factor it. When no factors can be factored further, you have finished. Always check by multiplying. That's one of the things that you guys have forgotten to do over the years. So remember, step one is always to find a GCF. In this case, we're going to factor out a 25. Whoops, I guess it would help if I turn my pen on. Let me straighten up the picture again for you. Alright, so if we're going to factor out a 25, we're left with t to the fourth minus 25. Look again and see if you can factor again, and you can. So now you get 25 t squared minus 5, and then t squared plus 5. And so you are done. Okay, the first thing you should notice about this one is that it has four terms. So because it has four terms, we're going to factor by grouping. After we check and see if there's a common factor. There's not one, so I'm going to drop in set of parentheses here and here. We're going to look at the set. What do those have in common? Well, I know if I factor out a 2x squared, I'm left with x plus 7. And then we're going to look on this side and see what we have in common. So I'm going to say a plus 3. That gives me an x plus 7. Are these two the same? They are. So we write them down, put the other two factors together, and we are finished. Now you should multiply them to check, foil it back, and see if it works. So x plus 7 times 2x squared plus 3 should foil back and give us the polynomial 2x cubed plus 4x squared plus 3x plus 21, and it does. So we're going to look at this one here. We have x to the fifth minus 2x to the fourth plus 24x cubed. So we're going to factor out a negative x cubed, and the reason we're doing that is because that lead coefficient x to the fifth is negative, so we want to make that positive. So we're going to try to factor that. So we're going to take out a negative x to the third, so when we do, we're left with x squared plus 2x minus 24. Now let's look and see if we can factor these together. First thing I'm going to do is I'm going to look here. This is negative, and this is positive. So factors of negative 24 when added together will give us a positive 2. So that means that our larger number has to be positive. So negative 1 times positive 24, negative 2 times 12, negative 3 times 8, negative 2 times 6, negative 4 times 6. So that would be the one, because if we said minus 4 plus 6, that gives us a positive 2. So we wind up with negative x cubed times x plus 6, and then x minus 4, and we're done. Okay, the next problem, first thing we're going to do, look and see if there's a GCF. There's not one, and it's a trinomial, so I'm going to look and see if this is a perfect square, and if this is a perfect square, and neither one are being subtracted. It is. So we need factors. You can do it the old-fashioned way. I'm going to look here. That's positive. So we know both our factors would be -9 if we do it the long way. But remember, we have two perfect squares. So if I say the square root of x squared and the square root of 81 is 9, if I go 2 times x times 9, does that give me 18x? It does. So this factors in x minus 9 squared, and so it works. So let's look at this one. We have a trinomial. We've got lots of things going on. We've got several variables in there with exponents. So I'm thinking we should be able to factor out something. So let's try 4x squared y to the third. 4x squared y to the third. That gives me 3 plus 5xy plus y squared. Now you can rearrange it in descending order if you want to see if there's anything you can do. I don't see anything else in this trinomial here, so I think we're done factoring. So this time all we have are letters, and it looks like it's a 4-term polynomial. So let's see if we can factor by grouping. This has an A in common, leaving just a B and a C. And factor grouping here, that's a W, and that leaves a B and a C. So we write down the common term, which is the B and the C, and then we group the other two together, the A and the W, and we are finished. Okay, 36x squared plus 36xy plus 9y squared. First and foremost, is there a GCF? No, there's not one. Let's see. Yeah, there is. Let's see if we could can we take a 3 out? Take a 9 out. Let's take a 9 out. So if we take a 9 out, we're left with 4x squared plus 4xy plus what? Y squared. That works. Now, can we factor this? Yeah, we can. So they're perfect squares. So this would be a 2x here. This would be a y. So if I say 2x times y, and then we do it times 2, does that give me the 4xy? It does. So that helped us factor. So we were able to factor pretty easily on this one. So we get 9 times 2x plus y, and we're finished. Let's check this one by multiplication, squared, and see if it works. So you leave the 9 here, so now we go 2x plus y times 2x plus y. So FOIL, we get 4x squared plus 2xy plus 2xy plus y, whoops, that's a y squared. And then we're going to multiply by 9. 9 times 4 is 36, x squared. Oh, I forgot to gather like terms. Let's do that real quick. That gives me 4xy. So 9 times 4xy gives me 36xy. And then 9 times y squared gives me 9y squared. So that one worked. Last but not least, are these perfect squares? These are perfect squares. Can't factor anything out. So this is a to the 4th. This would be 4b squared. So we're going to have a to the 4th plus 4b squared times a to the 4th minus 4b squared. This can be factored again. So bring down the first one. So we get a to the second plus 2b, and then we get a to the second minus 2b. And that should be our final answer. Do you guys have any questions? Let's check this one. So let's start with foiling this one. So we're going to FOIL. So we get a to the fourth minus 2ab plus 2ab minus 4b squared. Okay, gather like terms. That means these go away. So now we have a to the fourth plus 4b squared times a to the fourth minus 4b squared. So we're going to FOIL. I get a to the eighth minus 4a to the fourth b to the second plus 4a to the fourth b to the second minus 16b to the fourth. These two middle terms drop out, so we're left with 8a minus 16b to the fourth, and it checks.